can't say I'm not recording y'all. So yeah. So I'm guessing y'all are on the Discord server because y'all know about this. And then we have what's up?
Oh.
Yeah. Yeah, so it'll tell you to log in and then it'll take you to a static page. So you have to scan it again because it takes you to the stupid static page. Unless it says you're checked in, then you're good. So it may or may not work. And grab some pizza. Everyone good? Okay. So cool. Yeah, so we got YouTube, which is where we post the recordings. There's nothing else in there though, unfortunately. Yeah, so there's a survey that we're going to be sending out just to kind of get informed with where y'all are in machine learning. So if y'all could fill that out, that would be awesome. Basically, it's like a really quick questionnaire and just like be honest about it, because for the first paper reading meeting, if y'all are planning on going to that, if y'all don't know any ML, then we'll start with basic stuff like what is a neural network, how does optimization work, and we'll spend an extra meeting on that if there's a lot of people who don't know about it. But if a lot of people, if everyone knows like the basics of linear regression, then we can easily start talking about more complex stuff and more interesting stuff. So if y'all could fill that out, that would be awesome. Otherwise, we will talk about stuff that is complicated, I guess. But we'll send out the link later. So how many of y'all know the process of fine-tuning an LLM? I'm curious. Really nice. So real quick, I'm just going to go through this real quick before we get to actually fine-tuning the LLM. I just want to talk about it for a little bit. But basically what you do is the first step to training an LLM is you need to collect a shit ton of data. And I think it was GPT-2 or GPT-3, what they trained on. And this is a small data set. I think it was like 500 billion tokens. And every token is a part of a word. So maybe like be, see, and because. So yeah, they train on a shit ton of data. And a big part about this is the data quality matters. So you can get a ton of data, but you need a ton of good quality data, or else you're going to have a terrible LLM. And this gives it the knowledge that it has, but also, but it doesn't really make it that conversational. So GPT is a autoregressive model. That means it literally just predicts the next word given the context. So given, like recite the first law, then it would predict like A and then a robot. And basically what you're doing is you already know the sentence. So what you do is you train it to predict every word, and you can do this within one pass of the model. So you basically have this sequence, you know what the sequence should be, and you basically send that through the model one time, and the model predicts every next word. And this basically it'll slowly figure out the distributions for words given the previous words. So given this set of words here, it'll have a conditional probability of this should be the next word, and it has a distribution over all the words in its vocabulary or tokens. And that's called an autoregressive transformer. That's what every model does. Unless you're using a linear model, which I think I can provably show will never be as effective as a transformer.
I think we had a question, Gabriel.
Yeah.
Oh, yeah.
What's up?
So like, does ChatGPT collect your data so it better predicts like what it is?
Yeah, it 100% does. And then they just retrain it on that. So they probably do a mix of this here, which is pre-training or fine-tuning, and then RLHF, which is here. So basically, once you've trained this model on a massive set of text, it just predicts the next word. That's all you do for the entire data set, just have it predict the next word. Then it'll be really good at predicting the next word. So if you looked at the original GPT-3 or the original GPT-2 and you use it at all, you will ask it a question. It'll be terrible at answering it because it may continue it. It may continue your question because it's not made to respond. It's made to just continue text. So what you can do is you can do something called RLHF, reinforcement learning with human feedback, or from human feedback. And basically this gets it in the mood to kind of have a conversation with you. And the way you do that is you collect these pairs of data. So you need humans to rank some data. You just have an LLM you have a human prompt an LLM, and it gives you 2 responses, and the human picks which is the better response, and eventually you'll have a model that's much better. What's up? And yeah, so this is like how they make it talkative, which was a really big part of the LLM. Like, this is what made ChatGPT, because this was done for a while, and then they did this, which is what made ChatGPT chatty. So yeah, collect a bunch of pairs and basically have the model maximize the pairs that the humans like most. It also makes the model stupid. So that's a thing you get from this, but that's probably something we'll talk about in the first paper reading. Probably a lot. We'll probably talk about that. So yeah, basically what we're going to be doing is we're going to be fine-tuning small models like Llama. So basically we have this big model. Llama is this big model that was trained on a ton of text on a bunch of internet data, but the weights are open source, so we can take this model and we can do some fine-tuning on it. I'm thinking of doing an RLHF meeting for the next semester where we collect pairs of data, which is different from just normal fine-tuning. But yeah, we're just going to be fine-tuning it and basically adapting it to a specific task rather than it being this general model. So yeah, that's what we'll be doing. Would y'all be curious in like RLHF at all? I'm curious. Or would you rather do something more interesting for the next semester's meeting? Because right now we're doing like fine-tuning, but maybe we could do a meeting on like how do you make this model more chatty? Like we take a normal model and how do we make it more chatty? I think yeah. Cool. Well, because that's what we're thinking of doing next semester, maybe. So because this one we're just fine-tuning. So basically, for fine-tuning, you basically have this entire internet data. You train a model off that, so that would be Llama, and we can't do that because you need thousands of GPUs or millions of GPUs to do that. I don't know how many GPUs OpenAI has. So then once you have this model, you fine-tune it on a small data set, and basically it has this massive knowledge, but it doesn't really know how to, like you basically have it use that knowledge a lot better by fine-tuning on the smaller data set and be a specialized model. So it no longer has this global context of the internet, but you make it really good at this specific task, and that's what we're doing here. That's fine-tuning. So RLHF makes it like more chatty. Fine-tuning it makes it adapted to a specific task. So yeah, let's go ahead and do this demo. So this should be quick, I guess. We basically have 2 different collabs you can try out. There's this one here, which is the Elon one, and let me send out the link to this so y'all have it. So I'll just send it. If y'all can't see the resources, then you need to go to channels and roles and browse channels, and then you have to click on these. But yeah, I'm sending in the resources, so go ahead and go there. And if we open this up, we have this monstrosity of a collab. But we're doing this on Colab, not because Colab is good, but because it should work for everyone, and because you have free GPUs, because y'all probably don't have a really good GPU at home, and we're not going to be using SuperPod. So I already have this training, and I already trained one beforehand, which I will SSH into, and we'll play with in a sec. Go there. We'll play around with it in a sec. We'll talk to Elon, but yeah, we basically trained it on this big data set of Elon data on his tweets, which I think is fun to play around with. And we can get him to say things if we want, but how would he respond to certain things? Yeah, and basically we just trained it so that you have the favorites in front, and or fine-tuned it so you have the favorites in front, and then you literally just pre-train or fine-tune it on this massive set of data here, and it should learn to talk like Elon. So I'll go through real quick this notebook, just because if y'all want to try to fine-tune this on some data set, it may be beneficial to kind of talk about some of these parameters here. It's really easy to fine-tune this on your own data set. You can literally just clone this, and you can try it out on your own computer. You just need to put it in the right format, which is a pain. But as long as it's in this format here where it has like text and then it has all the text, then you should be fine. So I'll go through the parameters real quick while this is training. Basically, what we're doing is we're loading this in a 4-bit version. So models that are trained are usually 32-bit, but that usually takes up a ton of memory. So if we load it in 4-bit, it's not as precise, but it's a lot. You can fit it in a GPU because we have 7 billion parameters in our model. That's 7 gigabytes we have to store at the very least. And this GPU only has 15 gigs, so we can't train it if we were to store it 4 times, which is 32, if you store this in full precision, which is 32 bits, which is 4 times, that would be 28 gigabytes. So we store this in 4-bit precision. So if you're training this, the biggest parameters is probably LoRa alpha and LoRa R. Basically LoRa R, so we're training this in a low rank version. Basically this just allows you to train it in an efficient way. If y'all are curious about LoRa and how it works, we'll be talking about that in the first paper reading. But basically it's a way to, instead of taking this entire model, so this massive model, and fine-tuning that, we're going to be taking that massive model, but we're going to be not fine-tuning the whole thing, but fine-tuning it in this parameter-efficient way, which is what's called LoRa, low-rank adaptation of large language, or of transformers or something like that. I forget what it was. But yeah, basically this tells it how large to make the model. So if you make this larger, it'll do better, maybe, or it may overfit more. But if it's not doing that well, you may want to increase LoRa R. And then this basically tells it how much of the new data should I, or how much should I weigh the new data over the old data. So if you make this one, it probably won't act like Elon as much. If you make it like 100, then it'll probably do it way too much and be bad. And then these here are just, these parameters don't really matter. This one here I kind of messed up, so don't worry about this one. And then the model, we basically have different models. Wizard is just a fine-tuned version that was made by the community. They basically took Llama, which was pre-trained by Meta, and they made it a little bit better by having it kind of talk to itself. They made Wizard. And then these parameters down here, they don't matter too much, but you have parameters like the learning rate, and if you increase this, then it may learn faster and stuff like that. But overall, you could probably leave these as it is, and it should be fine. Yeah, so this is just like how you construct the data set. Basically, I constructed it in this way because I wanted to be able to put like favorites in there and then some number in there and have it respond according to that favorite count. So if I put like 100 in there, maybe it'll respond differently than if I put like 1,000 in there, because it's a conditional probability distribution that it's predicting. But you can literally make this however you want, as long as the data set is in the format that you want it to be in. And it's in this format here, this text format. Basically, if y'all want, y'all can reach, if y'all want to, if y'all need help with this, you just make a Hugging Face data set, and it should look like this. But if y'all need help with that and y'all are trying to fine tune, just reach out to one of us and we can help y'all out with that. But basically, as long as it looks like this, you can use the script here, and you just change out like one line, and it should work. And if y'all want to do this on your local computer, you can do that. Yeah, so it's training right now. I'm going to go ahead and stop it, and we'll see how well it did. There, and I think it's 300. So whenever it's done training here, or fine-tuning, I think it finished, yeah, it did like 300 epochs. You can go over to the files, and you should have these outputs over here, basically checkpointing the model at certain steps. Yeah, 381. So I'm going to go with 375, which is the latest checkpoint we kind of have here. So you just change this path here to the latest path, or one of them. If it trains for too long, it may overfit. If it trains for too little, it'll be too close to the original model. And then you just run this cell. And this cell basically is taking the new weights and it's merging it into the old weights. Nothing too important there. Like, if y'all are interested, again, we'll be talking about LoRa in the paper reading session. But yeah, this is just making it, this is just merging all the weights together so that it actually uses them. And then this final cell here, this one will be how you play around with it. So instead of doing that, though, I have a much faster version on my PC, which we will be using. So yeah, let me do that. But But yeah, if y'all got any questions about fine tuning or anything, I would be happy to answer them. Yeah, did y'all find the slides on Discord if y'all are trying to use it? So if you go to Discord, it is under resources, and if you don't see resources, which Discord is stupid, then you're gonna have to go to channels and roles, and then you're gonna have to go to browse channels, and then you find resources. It should be there. If it's not, then Discord. I'll send it in chat. There's everything but resources. That's pretty cool. What if I move it there? Is it down out there? Well, I put it in chat. I'll fix the resources. We've had. Is it there now?
Yeah, I found the slides. Thank you.
Yeah. Oh, it's in chat. So resources just isn't there. It's just like we have everything but resources. That makes sense. I guess just find it in chat and that'll be fixed. Can nobody see resources?
Yeah, this is so weird.
It is clearly there. Alright, yeah, just look at the chat then and we'll fix that. Cool, everyone's on it now.
Resource keyword.
Hmm?
Maybe it's a keyword in Discord.
No, it is a special channel, but that channel's always had problems. We'll fix that. Anyways, we can talk to Elon now, so let's get a bunch of tweets from Elon. If y'all want to talk to Elon at all, we got this. But yeah, I guess the main thing is just showing off how to fine tune here. Right now it's merging. Hopefully it'll be done soon. But yeah, hopefully you can play around with this and maybe with your own data set. It takes like an hour to train and that's on Google Colab, which is bad. So if you have a good GPU, it'll be a lot faster. You can just download this using file and save or save a copy.
Oh yeah, why don't you set like the learning rate to the max and just like set it like that?
Yeah, so that has to do with like basically if you have it set to the max, it'll like if you look at the learning rate landscape, or basically the model's going to be really bad at optimizing. It just isn't going to work. And that has to do with how the optimization works. So the higher you set it, the faster to learn. But it's basically trying to find a minimum, and it'll be bouncing back and forth as opposed to going down into a minimum in terms of the loss.
So it won't be like specific. It'll just keep like going.
It'll basically just bounce around everywhere because it's so high, and it's making like I could draw it out, but actually let's do that.
It's like when you can't focus on something.
Oh, like you're just switching to the next thing like every second.
So like if we had this here, and we want like we have a model here, and it has some loss value, and we want to find a set of parameters that are good. We basically want to find this minimum, but if it has a large step size, it'll basically be bouncing around here because it has a large step size. Like if it's right here, it'll say, oh, the minimum's in this direction, so it'll bounce all the way over here. And then if it's right here, it'll say, oh, the minimum's in the other direction, so it'll just keep on bouncing around and it'll never find the minimum. But if you set it low, if you set it too low, then it'll slowly inch down. Yeah, so that's the reason why you can't set it too high. And you actually set it lower whenever you're fine tuning because it's already in like a good spot in the landscape, like it's already in a reasonable spot. And if you make it too high, then it'll just unlearn everything. So it's actually lower than you would usually set it. Alright, cool. It looks like that cell finished running. Yeah. Does everyone know gradient descent? There you go. There's your explanation. Yeah, but if so, we have this form. If y'all could fill it out here. For those of y'all who came in, basically asking what level of knowledge y'all are at, so that we can like better. So we can.
Can we update the title of the slide?
What do you want? What do you want it to be called?
What's your level of experience?
I sent out the slide. You should have done that. There we go. What's the difference between? I like that suggestion. There it's updated. Yeah, but this space. Yeah, what's that?
It asks for permission.
It's asking for permission. Let's go. Let me fix that.
Also, Gabriel, can you break down the data you loaded that you used to train this to tune this language model? Just curious.
The source is in the notebook. So the Hugging Face repo, or whatever they call it, is in the notebook. And if you go to that on Hugging Face, you'll be able to find it.
I know, but I'm looking at the data set which has like ID, username, user location, user description, user created.
Is this
Like
Which
I mean that's just the tweet, right? That's all the tweet data.
Can I make it so that people can use this thing?
Yeah, I think the notebook includes all the preprocessing.
Yeah.
Text and everything. So I guess Gabriel could walk through that, but
I'll walk through
pretty
it.
straightforward, right? Just
Yeah, I'll walk through it.
I'm
Does
just
it
a little
like?
bit confused because are you wait,
I'll send it out in the announcement. I don't know why it's not working. Yeah, let me walk through that.
because you're training on every single thing, right? Don't you only want to train on just the text?
Yeah. What do you mean by everything?
Because the data set you're that you're returning.
do you mean all the columns in the
Oh,
data
never
set?
mind. Okay, wait.
Yeah.
So wait, you removed text.
Yeah. So let me walk through this
So what
function.
did you keep? I'm so confused.
So let me walk through this function. Basically, what I'm doing is I'm taking this data set. So I'm loading in this data set here,
Yeah.
which has all the tweet data.
Yes.
And then we go down here, and I'm basically removing every column after it's mapped. So this is a post remove.
Okay.
And for every part of the map, basically we take the text. So I basically already pre-processed it, but I can send you the script for that. I actually have, if I go here, I can send you all this repo, which I think still works. This one. Basically, this has everything there. So this has the data creation. That is not it. This one, which basically is like a more complicated version that cleans out everything. This got the Reddit data, and I can send this to you. But basically, all it does is it just concatenates stuff and cleans it out. And then here we're getting the text and the favorites, so those columns, just concatenating it together in a nice way, right here. And yeah, one point here is to make the model stop itself. I add a pad token. So we basically have all this text, but to make the model stop itself, you put an extra pad token at the end, and then you have the model learn that one pad token. Because if it doesn't, then it'll just keep on predicting text. But if you have it predict a pad token at the very end, which is just an arbitrary token.
That's just when it knows.
It's what tells you like when you should stop.
Yeah. Basically, like if you don't do that, the model will just learn how to continue text, but it'll never learn how to stop itself. But if you add this, it will learn how to stop itself. So you add this at the end, and it does that. And this is just a messy way of doing that. And in the end, you have these input IDs, which are just the IDs of all the tokenized values. You have the labels, which is just that shifted, and the attention mask, which is basically just an efficient way of training it, as you would expect.
Sorry,
And
why
then,
do you need the attention mask?
oh, so we'll talk about that during the paper reading, but a quick summary of why you need the attention mask is it allows you to train efficiently. So if I have a ton of sequences, I could train one sequence at a time, but the problem is the sequences are not the same. So imagine I have this sequence and this sequence, and I want to train them in parallel. So I send this to the model in parallel. Since you concatenate things in a matrix, you can't concatenate two things that are different size. So you have like this, maybe this is 400 and this is like 100 in terms of the number of items you have, in terms of the number of tokens. You can't concatenate those together, so you can't train it in parallel. But if you pad it with a bunch of pad tokens, say this one has 300 because you need to pad it to 400, you concatenate it together, but then the model will learn, oh, an easy way to do well is just predict pad tokens. There's 300 in this sentence. Why don't I just do that? So you put the attention masks that it doesn't learn those. But we'll go through like more mathematically how you do that
Interesting.
in the paper reading.
Wait, what's like a high? You said there's like a bit or something, and you showed like ranges, like ranging in like billions, but then you said they were small. Like, what's a high bit? Is it bit token rate or bit?
Oh, bit.
Back
Wait,
in the slides, right?
oh, back in the slides. Here?
Yeah, yeah.
Oh, tokens. Yeah, so just think of a token as like a piece of, or a word. Yeah, so a high, I don't know, what do we think GPT-4 was trained on? Like,
Double trillion.
yeah, a lot of trillion. But then they also train on,
I think a really nice way to illustrate it would be to go on the, I think TikToken.
Yeah, if you search up like TikToken web,
Yeah, it's
there
like
OpenAI has a
nice
nice
web interface,
visualization of what a token
and
is.
it will tokenize the text. you
TikTok.
type.
Not TikTok.
No.
TikToken web.
Don't put a space between tick and token.
This one?
Yeah. Or I don't know if that's, I don't know if the first,
I
no,
think-
go to
I think-
OpenAI
yeah.
platform, go back.
All right.
And you see the OpenAI link. Yeah, that's a good one.
So when
So
you
scroll down a little
when
bit.
you prompt the language model, it will chunk it like this.
Oh,
So-
interesting.
Use like the more complicated word, or like some random word.
All right. I'm not creative.
Fair enough.
Fragilistic astrological
Yeah.
I don't know how to
I can't spell that.
Each
All right.
color that you see is a token.
My goodness.
So it does.
That's how the
So
language
that's
model
what it
works.
sees when you give it text.
So does it see based on more like the color or just the value?
The color is just a random color. It's just there to signify that there's a split between the tokens.
Uh-huh.
But like when you give it that like that, that's what you're giving the model. Essentially, you're not giving it letter by letter, and you're not giving it the whole word. You're
It's
just giving it like part of a word.
It's word piece. It's called like word piece or sentence piece depending on what you're.
Yeah. So
Basically,
Google's BERT model uses sentence piece.
BERT.
OpenAI uses tick token. That's what they call it. And I'm sure there's other ones. This is something that they decided. A model didn't come up with this. Like some intern or something, someone.
No.
decided what all the
No. The way they do it is they basically
Or they use word frequency or letter.
yeah.
bigram.
Well, like the idea is if you have a common stem, so I guess they don't do that here, but if we have ing, which is common, then it would be good to get that ending. So
So you don't have to.
yeah.
So you can reuse it.
So they basically do some word frequency analysis and do this. But basically, it's if I give you a ton of text, a sentence, a paragraph, it's how do you break that up so that you can feed it through the model? Because the model is predicting token by token. Given favorites, it'll predict colon, and then given favorites colon, it'll predict space, and given all this,
And there's a limited number
Pretty
of
wash.
there's like a limited number to the types of tokens. Like the so say like purple's like 0, green's 1, and so on. There's like a limit to that list of token types. So they're trying to target like a trade-off where you don't have too many different types of tokens, but your model still learns like relations between text.
because you could either have like a ton of just every word, which would be both sparse and way too many tokens, or it would be very dense and way too many tokens, or you could have like every pair, which would be even more tokens probably, or no, that would be a lot less, or like every character, which would be like 26 tokens, or like 500 for the number of ASCII characters or something like that.
And then you're giving the model like a ton of like text when
Yeah.
you give it a sentence.
So you find somewhere in the middle, and that's where word piece comes in, how you tokenize it.
So interesting, man. I didn't know about any of this.
Yeah. I mean, we'll go over this more in the paper reading if you're curious though.
Try to visit that website and play around with it.
I'll put it in the slides.
If you
We'll
ever
make this
wonder why,
prettier.
Why GPT can't tell you that strawberry has 3 letters in it? That's the reason why.
Yeah, if we put let's see.
I'm sure they fixed it.
That's why.
Yeah, so if we give it
It's
straw,
3
then it,
tokens.
yeah.
It's funny because when you hear the word strawberry, it's one word to you, but for GPT, it's 3.
Yeah.
Oh my goodness.
Here, token IDs. Oh, here we go. Yeah, so these are the token IDs in the vocabulary. So this is what it's mapped to. Basically, you're mapping every token to a specific number. So this is what the model sees, which you then turn into vectors. But this is what the model sees, and it's just a correspondence. So favorites would be this token here, and colon would be token 25. So this is what you're feeding into the model. It's mapped. Yeah, and that's what whenever you hear tokenization, it's chunking up the text and sending and then getting the integer correspondence to that, and that's what we have here. So you have a tokenizer, which all it does is it takes the text, chunks it up, and does that.
So the ChatGPT treat the entire sentence as one vector?
Yeah. Well,
one column vector?
It's one row. Yeah, one row vector.
It's more like of a matrix, right? So the number of words that you typed by the vector that is used to represent the line. Does that make sense?
So every one of these is going to be mapped to a vector. So it's a list of vectors. So it'll be a row. It'll be a matrix.
It's a matrix, and that's like the column. Like the number is the column
Yeah.
that you want to take out of the matrix.
So basically, in the ChatGPT knowledge base, 25 would be like the whole column vector.
It would be so you basically have a column vector corresponding to every integer.
Okay, cool.
So, and then you just stack those together, and that's your text. So we would get the integer for this, the integer for this, or the vector for this, the vector for this, the vector for this, stack them together, and then you do some extra pre-processing, and then you throw that through the model, and it
Do
does
we know the
eventually.
definition of each vector?
I think it's 500
I mean, it depends on.
Yeah, if you're using BERT, back in my day,
It depends on the model.
but
like,
so I mean, 512 is pretty simple.
no, it's
But
not.
for GPT, it's way larger.
Yeah, if you like lived in 2017, you would use 512.
I think 2048 is what they used
Yeah.
on the original.
I think it's 2048.
paper.
Oh my.
I'm really sorry, guys, but I gotta go take my test now. But thank you so much for educating me on.
Good luck, man.
Yeah, good luck.
You're gonna show us some Excel too.
Yeah.
Excel?
I don't know what it is, but it is way larger than 512. 512 was BERT. 512 was BERT. So I think it's like 4096 now. I think I remember it being 4096 in some of the models. Actually, I think we can look here if we look at the config. Yeah, 4096. And then,
Oh, wow.
yeah, it's freaking massive.
That's for the 8 billion parameter Llama 3 model.
Yeah.
That's not GPT.
Yeah, the
That's
GPT
the one
is
that
fine.
runs on your computer.
Let's see what the 80 or what's the largest one? 300 billion?
305.
305?
No, I thought it was 405.
Oh, 405.
405.
Right, yeah. Yeah.
Let's see what this month.
It might even be the same.
16,000. I don't know. I don't even think I could store that on my GPU if I wanted to. Yeah, so that's what they embed it to. And then we'll talk about like positional encodings and all that as well. But also for every integer you're storing, you actually store it 4 times because you're storing it at floating point 32, not floating point 8 whenever you're training the model. Or floating point 16 probably, so you store it twice. So to store one vector, that requires how much memory? 16,000 times, that would be 2. Let's see. That would be bytes to, I don't know, megabytes. 30, wait, that's wrong. Probably 32 megabyte. Oh, wait, that's megabyte.
I don't know why it's giving you that.
Yeah, kind of stupid. And then if we had like, I don't know, a lot of these, and that's just to store the vector. To store the weights, that's a different story. The weights are massive. We'll show that later, or we'll show that in paper reading.
Speaking of like token indices,
Yeah.
what does it really mean? Because like, man, so what does it really mean when you like train BERT and it says token indices sequence length is longer than the specified max sequence length?
So if you train it on like 512, let's say we train it on a sequence of 512. Basically, if you go beyond 512, the model has never seen a index greater than 512, And whenever you're embedding the tokens, you basically give it the embeddings, but you also give it a positional encoding.
Yes.
And if you go beyond that, the model will be confused because it's never seen a positional encoding greater than 512. So it can extrapolate a little bit, but beyond that, it sucks.
So you have a vector. So you have like a vector, or you have a bunch of column vectors representing your tokens.
Yes.
And then you have another set of vectors that represent the positions
Here.
that each token will be at. So in the case of like whatever you're using right now, they probably only have 512 positional embeddings or vectors. And if you give it 513, there's not going to be another one.
Right.
So then what do you make that one?
Okay.
Since it's never
that's
seen
why
that.
it's not. That's why it's not working.
But why do like models like BERT limit the maximum sequence length to 5?
That's because you
That's
get.
just what they
yeah.
trained it on.
So the problem with attention, which is what the transformer uses,
Yeah.
is it's quadratic in terms of memory.
Okay.
So it's basically how much memory can I, or how much memory do I have? So if you increase the sequence length by double, it increases it by 4 times the memory.
So that's why you use sliding windows.
No, you don't use sliding windows. If you want a bad model, you can use sliding windows. Or you could use things like Mamba. I think I can provably show Mamba is never going to be as powerful as softmax attention. I'll have to show you all the proof. There's not really a
Paper
proof.
reading?
Yeah, I'll show you all there. But yeah, if you use sliding window, then it basically limits the context, and it's not that good, and you're basically doing a convolution at that point.
Yeah.
So no, don't do that. Use softmax attention. It's all you need. Trust me. It's all you need. Sorry. Yeah. Now, do we want to chat with Elon a little bit?
But yeah, before it was like really hot, and now it's freezing.
So I should be able to prompt it. Yeah, but if y'all have any more questions about like the transformer and stuff, like we should probably I can go over it with y'all.
This
I'd
was
love
supposed
to.
to be the non-technical
Yeah.
meeting.
So yeah, we'd love to go over it in the paper reading. You should come to the paper reading. It'll be in 2 weeks.
Okay, I'll come.
Yeah, let's go. You better be there.
I will be sold. No, I probably need it at this point. Yeah.
Why do you need it?
Yeah.
Optimus Prime?
Optimus Prime, exactly.
Because my model freaking sucks. That's why I need it.
You need an Optimus Prime, you know. Yeah, true. Michael Bay your code. What do you ask him?
What did I ask?
Ask him the
Type in
will
idle.
AI kill us all?
Yeah.
He's gonna say yes. Oh, I should ask him who's gonna win.
Yeah.
Ask him about Jerry.
Jerry.
How would Elon
The
know about-
2025 election result will be :
Oh, ask him about his opinion on Elon Musk.
Elon Musk.
Elon Musk.
Ah.
Will be reversed. Okay, that's wrong.
Ask him about Trevor. It sounds like what he's doing.
Yeah, it sounds about right.
The super sarcastic.
Elon Ma. How do you spell that? I just don't know how to spell it.
YILONG and then MA.
There's no way I would have got
Oh,
that.
he's related to you?
What?
He's related to you? He's the same Wait, what? Yes, Bob. That's him.
Why is it doing that?
It just returns it. Where's the link go to?
What?
I got the link. Just gives emojis? Wow.
Oh, that's awesome.
It's like a very risky thing to be doing.
It's fine. There's been riskier here. The negative Reddit bot was probably the worst idea.
Make sure
We should show that one working right now.
Oh, the Reddit, the
Yeah,
negative
yeah.
Reddit bot. Yeah, that thing got burned. I think it's tokenizing the \n wrong. Can I do? Yeah, that may work. It really.
There's some key that lets you give in backslash n. It's like alt enter, control enter. It's something.
I'm gonna
That's
try
what
that.
I'm looking for.
Yeah,
Well, which one was it?
it's not alt to enter. It's not. Oh wait, I think it is control enter. You may be right.
Control enter.
Oh no, it's not. Wait, where was it? Was it here? Oh no! Don't crash on me. Let's try this one. The one that the collab trained. This one should be a lot worse. Oh, I shouldn't even have reply. I should send text. It's really slow at loading the model.
You use Python?
Oh shit.
Yeah, that would have been a good question to ask. Do y'all know how to use Python?
No.
It's a little late.
That's fine.
Bit late.
You can just click run on all the cells and it'll work.
In worst case scenario, you can just copy the content of the cell and paste it into ChatGPT and ask it to explain it to you.
Yeah, that's actually.
Yeah.
It works. Oh my god.
It's the reason why Google found a whole Python development team.
Prob-
It really works.
Imagine a probabilistic model taking your job.
A whole Python development team. Wow.
Imagine getting replaced by a math equation. Couldn't be me.
Is that true?
You're probably literally
Hmm?
here.
Is that true? You were there, right?
Yeah, I got fired.
You got fired as an intern?
Yeah.
They were just like,
Yeah, they know.
ChatGPT interns.
We can use ChatGPT instead. We don't need stupid interns.
You can replace it.
They had a Gabriel agent.
What?
I was saying that they had a Gabriel
An
agent.
Asian version of Gabriel and Elon Musk.
You guys use ChatGPT in PhD too?
Of course. I'm a ChatGPT rapper.
Yeah. Oh, you're a rapper?
Point.
Yeah.
You might as well just ask if they use
Oh,
it.
that's stupid.
Yeah. Oh, yeah, it's true. Okay, I use it like ChatGPT like at least like an hour a day, just like asking questions. No, you saw it's like it's super useful for.
You'd be
editing.
shocked too because only like last week did you realize that you can edit what you said with ChatGPT.
Wow.
I mean, you could just ask it to fix it too. The other. The
How-
little
Pretty
bastard.
helpful in writing. Paper writing.
Yeah, you can write a whole paper. No, doesn't help. Like what?
We need to ask about Elon Ma again. So if you put a space, it may not work because the way it tokenizes it, sometimes it tokenizes the space with the previous word and sometimes it doesn't. So it may act up if you do that. If you add a space or if you don't add a space. It is cooking on this one. I don't know what it's doing. Oh yeah, that's awesome, man. We need more hats.
Got it.
Need to,
This is. So favorites are like, I never use Twitter, so is favorites just like.
Why do you have that
I'm
pre-code?
curious, yeah.
what, the favorites?
Probably came to
Yeah,
best
I was
question.
gonna.
I'm curious to see if it learns a conditional probability on the favorite count. So if you like put a certain count, does it bias it towards something else? Because it did for Reddit. If you put a negative number, it would be a lot more negative than if you didn't. I could see if I can find my Reddit notebook, but that one was very interesting.
Like the negative numbers for like your upvote, downvote?
Yeah.
Oh, wait, in that case, the negative number is just unrelated to the content. Like
For what?
in Reddit, like if you put a downvote,
Yeah.
it means it's not usually has.
Yeah.
The comment has nothing to do with the question.
Yeah.
That means you just don't like it.
Or it's
Like when I see downvotes, like I like look for the downvoted comment because that one's usually the best one.
well, there's a controversial. Well, Reddit also has a controversial thing, right?
Oh, yeah, they do, yeah.
Controversial, so it's like how much negative and positive.
Yeah.
Well, I took all the negative. That's what I was saying. Whenever I took all the negative data, it was like insanely bad.
Good?
It was insanely good at what it was
Yeah.
supposed to do.
Yeah.
It was just, yeah, it was interesting to play around with it. Yeah, there's all this. If y'all want negative data, here's all the Reddit negative data in the political subreddit. This is awesome. Training a bot on that was, yeah. But if we have this here, I put the score, and if you put a negative, it was a lot. It was definitely different. You could tell. That's what I was trying to do here, but it doesn't seem like it probably didn't learn it because favorites seem to be more stochastic than like Reddit votes. Like a lot of the favorite counts are insane. It may be because Elon gets favorited a lot with all of his fanboys. What if I put 0? No favorites. Yeah, this one didn't train long enough, so it's really bad. This one's much worse than this one. And also, a lot of them were replies to it. I should have probably planed that with like a BERT model to go through and say, is this a reply to something, or a GPT model and say, is this a reply to something or not? So, yeah.
Is the reply just like spam with?
Well, it's him replying to someone, but if you don't have the context, then it doesn't matter. The Yen LeCun data is a lot better to train on. If y'all want to try that one, this one, you can also have him reply to you. So if you put like the text, then you can have him reply to it, and you can add the number of likes rather than the Elon one. But this one wasn't trained for long enough, so I only trained this one for 375 or 380 epochs and 380 steps, and the number of epochs or steps was 2,000 for 3 epochs. It didn't even go through it once. That's why this one is so much better, because I actually trained it for a while. Run it again.
How long did you train for?
Just 3 epochs.
Oh, just
Yeah. But yeah, there you go. If y'all got any questions about fine tuning or anything, let us know. And I mean, I would be happy to help out. Would you be happy to help? All right, I would be happy to help.
So, but I'm assuming that if I take like my own data, like text I've written, maybe my messages or something.
Yeah.
I'm assuming it's going. If I train for long enough, it's going to talk like me. Right?
Yeah, so I actually trained this on one of my friends, on my friend's Discord data. I'm not showing it, but I did do that, and it was really good. So if y'all wanna take like a ton of text, you could like clone your friend and have it respond in your friend's voice, and it's very funny. Yeah. So and all you have to do is just throw it or use this script and train it for a while. Just so one thing to note is that these outputs will be killed. It may be better to. I'll send this link out as well. This fine-tuning script with everything in it. These will be deleted because of collab, so you'll have to go to, as long as you go to models, and if there's outputs, and as long as there's one you're happy with, you can go to like merge model, and if you download all these, you can always import it again, and then it'll be fine and you can run it. But if you don't do that, it'll be gone forever, and you'll have to retrain the thing, which isn't that big of a deal. But if it takes forever, then it sucks, because this is slow. They're using TPUs, and TPUs at Google are they give you the garbage ones, so it's not going to be fast. I guess you could always upgrade.
Like the cheapest NVIDIA Tesla GPU. Like this is like, or not Tesla Turing GPUs. This is like a few generations behind.
Oh yeah, they're
They've
using
had this for a while.
they're using the T4 GPU. Yeah, not a. They usually use a TPU, but make sure to change your runtime type.
Yeah, don't do it on CPU. Or
Yeah.
you're gonna be waiting for.
You're not
while.
you won't have anything. If you get an A100, that's pretty good. That would be
That's
awesome.
what you get when you pay for it.
Yeah, you got to pay for it. Or you could run it on ZeroPod if you know how to do that. Or you could run it on RunPod, which would be pretty good. But you then you have to pay, and if you don't, you probably don't want to pay. That's why we have Colab. So yeah, I don't know. Play around with it and fine tune it on some data. Y'all come up with. I should try to fund myself with this. I think that'd be funny.
Every Discord meeting, like on the Discord, it'll just be for fun.
Yeah, it'll just you won't know if I'm speaking. You have no idea. I should do that.
You can make a bot, right? I can
Yeah.
upload this automatically.
Oh yeah,
post
yeah.
on Reddit or
Well,
something.
yeah, you can make a Discord bot. If you see a bot enter the server, it's probably my bot.